Now today we're going to talk about reference frames. Quick note, when we talk about reference frames, we're talking about inertial reference frames, which is a frame that is not accelerating. If you're thinking that the Earth, that's the Earth, spinning, wait, it's accelerating? True, but it's not a big enough effect to count from most measurements that we're going to talk about in this class, so we're going to brush that under the rug. So don't worry about that. A note on notation. This is the velocity of A as observed by B. So this is the person who measures the motion. All right, the second notation. And the first letter is what they're measuring. Another important equality is VAB. Velocity of A as measured by B is the exact opposite of velocity of B measured by A. If we think about this, here's a person, they're running this way. To the person on the right, this person sees this person running forward. Sorry, I'm not pointing. This person thinks this person over here is moving at them. This person thinks this person is running at them. Right, and that's where the negative flips. It's just a difference in perspectives. So what I'm looking at, I've set up a reference frame, and I want to figure out how far, what is the position of B as measured by A at this distance. So to do this, I'm going to figure out how far B is in reference to the truck, so the position of B as measured by the truck, plus however far this is, which is how far the truck is as measured by A. Now if we look, we'll notice that the outer subscripts match this term over here, while the inner subscripts of the truck and truck match. This guarantees that this is a plus sign. Very important, if ever you get confused, you can kind of use this little trick to figure out what order should things be. So the inner terms match, and then the outer terms. The outer terms are on the left-hand side, inner terms match. There should only be one way this works. So let's look at velocity. We know velocity is the time derivative with respect to position, and oh, lo and behold, velocity behaves in the exact same way. Now there's an errant parentheses. There, now it's gone. All right, so let's look at an example real quick. So in this example, I've got person A moving towards person B, and then person B is moving towards person A. So I start by writing down my knowns. I need a stationary observer. I like to use the ground, G, and I want to know what VAB is. So we'll take a look. We'll look again. Here are our, that matches, inner terms match. All right, so I know I've set up the equation correctly. And then I'll move this VBG over to the other side, plug in my known values, and I find out that person B measures person A's velocity plus 5 meters per second, which means they think this person is moving to the right. While person A sees person B, velocity of B as measured by A, this person, according to person A, is moving to the left, which is exactly what we'd think. Let's look at a second example. So we've got a cat on a truck. So we know the cat is moving, 2 meters per second. Again, we're going to do the same type of matching. The cat relative to the ground is the cat plus the truck, plus the velocity of, those should be subscripts, G. And we add them together, we get 22 meters per second. Let's mix this up even more. Again, some of these examples seem a little intuitive, but I'm trying to get the formalism, and it's easier to get the formalism on something where you already have an idea of what the answer is going to be. So now we've got a walkway. So a person's moving on the walkway 5 meters per second. Person on the ground, so the velocity of the person on the walkway as measured by someone on the ground is 3 meters per second. So again, we try to put our terms together. Inner terms match, those match, so it looks good. And again, this is person on the ground measures as the person on the walkway plus the velocity of the walkway to the ground, which makes sense. We'll do some rearranging, and we find out that the velocity is negative 2 meters per second as the velocity of the walkway, which makes sense because if a person on the ground sees them as moving slower, then the person on the walkway actually thinks they're moving, and it's because the walkway is going backwards. So I hope this was helpful. I will see you in class. But before you go, just a quick recap. Make sure your terms match, B. Make sure the A's match on the outside. Make sure those are the same. That's a good way. It's a mnemonic to figure out what's going on. Your velocity is not going to change. Remember, this is just for inertial reference frames, not accelerating. And now I'll see you in class.